Numbers, page 3. Calculate the value of the expression square root of 2 times the quantity y minus x when y equals 3 and x equals negative 1/8. This is just an easy calculator problem. They're just checking to make sure that you know how to type into the calculator without ruining the PEMDAS order that the calculator is going to respect. So we have this equation, and what we're going to do is we're going to substitute the y for 3, right? And the x is going to be substituted by negative 1/8. And, just to be extra careful, what I'm going to do is, not only am I going to substitute the numbers, but I'm going to put the numbers that have been substituted in parentheses, and then it'll be extra careful that any negatives are going to be grouped together with the number. Do you see how the negative 1/8, the negative is considered together with the 1/8, okay? And it doesn't matter in this case, but in other cases it's going to matter. So let's type this in. Square root 2. I'm just going to go ahead and put all the parentheses on, and then I won't have any disasters. Remember, negative 1/8, you need to use this negative sign. It's not the same as subtract. Alright, so do you see I have 2 parentheses there? And now I'm done. I can hit enter and I'll get 2.5. Okay. State whether your answer to part 8 is a rational number or not. Yeah, 2.5 is a rational number, right? You could get it by doing 5 over 2. So yeah, it definitely is a rational number. Yes. Write down 3 rational numbers between 9/5 and 11/6. Now when you get a problem like this, the easiest thing to do is to figure out what the decimal representations are for these fractions, because then it's easy to figure out 2 or 3 numbers between 2 decimals, right? So between 1.8 and 1.83 repeating forever, there's of course 1.81, there's of course 1.82, and 1.83. These are 3 rational numbers that are between those 2 numbers, right? Okay, this is the 3. Write down 3 rational numbers between negative 28/13 and negative 2. So same thing, we're just going to put 28/13 here, and then we're going to find out what the decimal representation is, 2.15384, etc. So it's negative 2.85384 for 6154, etc. Probably goes on for a while, or maybe forever, and negative 2. So negative 2 is just there, right? So we could put negative 2.8, right? Negative 2.8 is to the right of negative 2.85 on the number line. We could put negative 2.5, and we put negative 2.1. Those are all numbers between those 2 numbers. 3 rational numbers that are between those. And we could even do something fancy, like we could do negative 2.1 repeating forever. That is also a rational number because it repeats the pattern. Okay, how many rational numbers are there between negative 28/13 and negative 2? Oh, well, there's an infinite number because you can always find a rational number that's halfway between 2 other rational numbers, and so that will go on forever, right? Is pi a rational number? We know that it's not, right? The decimal expansion of pi from the GDC is 3.141592654. But these are just the first 9 digits after the decimal point, okay? So actually, the pi has infinite number of digits come after this, and they don't repeat the pattern ever. Calculate the length h of the hypotenuse of a right-angled triangle with sides 2 and 1.5. Okay, remember Pythagorean's theorem. So to get h, h squared is equal to each of the 2 legs squared. So 2 squared, 1.5 squared. So 1.5 squared is 2.25. So 2.25 plus 4 is 6.25. And then h is equal to the square root of 6.25. Which is 2.5. Okay, so h is 2.5. State whether h is rational or irrational. It is rational. Okay, calculate the area A of a circle with diameter 10 centimeters. There's the formula for the area of a circle. So we have the diameter is 10 centimeters. Remember, the radius is half of the diameter, so the radius would be 10 divided by 2. So it would be area equals pi times 5 squared, which is equal to 25 pi. Now we know that pi is irrational. So what about 25 pi? Is it also irrational? Yeah. Any number times any rational number times an irrational number is going to give you an irrational number. Okay? And so that's it for page 3.